For the most part, everybody did this one pretty well. Maybe I'll hand them back first. Let's try that again. So, for the most part, this one was done quite well. The only little boo-boo that a lot of people made was that it's 1 centimeter equals 10 centimeters, so that when you measure from there to there, and it's actually 20 centimeters, that converts to 200 centimeters because of the scale, which is equal to 2 meters. So for the most part, that was the only real mistake that I saw, because you'll notice here everything was fine, but over here it says, what is the average velocity of the ball in meters per second? In meters per second. So you must be working in meters. Okay? And so, average velocity, V bar equals d over t. What's the total displacement? 2 meters. What's the total time? 1, hoping you don't need your calculator for that. 2 meters per second. Please include your units. They're important. What is the final velocity of the ball? We know that the ball starts at initial velocity of 0. We know the average velocity, and so to find the average, some of you tried to show me how you did this. You just sort of went 0 to 4 because you didn't know how to show it. I accepted that for now, but I would really like to see something like this. What's the final velocity? 4 meters per second. I was unpleasantly surprised at the amount of mess that people were able to create in those 2 questions on their sheet. They really weren't very well neatly done, with a few exceptions. Lots of people were quite messy there. What is the average acceleration of the ball? Acceleration is delta V over delta T. Do I have the delta V? Not exactly. What do I have? I have the average and I have the final. But if the initial is 0, what is delta V? Vf minus Vi. In this case, it's 4 minus 0. It is the number 4, but not because the final is 4. It's because the final is 4 and the initial is 0. So now you would go 4 over, what's the time? 1 second. 4 meters per second squared. And yes, the meters per second squared is important. I have some people that like to write their solution like this. I don't know why. Or they put like the answers like this. They put the 4 like there, without the equal sign. I mean, they do all sorts of silly things. We don't know why. Put it in order, please. See how nice that is? That's what I want. Are we good? Okay, now here's where we're looking at graphs. Some people didn't even see question A for some reason. I don't know why. They missed it completely. From the graph of velocity versus time for a car shown below, determine V inst at 20 seconds. The instantaneous velocity at 20 seconds. This is a graph of velocity, so what do? I just read it right off the graph. 20, right there. What is it? About 17. 17 meters per second. V inst at 60 seconds. Read it off the graph. It's about 22. Right? 21, 22, something like that. Okay, now A inst at 30. How do we find instantaneous acceleration at a certain point? We find the slope. I had some people that all they did was they went like 23 over 30. They took the points right there because it's up 23 over 30. They went 23 over 30. Why is that wrong? You have to draw a tangent line. That's right. Right? And you have to find two different points on that line. You do not find the slope of the line just by taking the y-coordinate divided by the x-coordinate. That only works when it goes through 0, 0. Mr. Bennett, that one goes through 0, 0. Why doesn't it work? It's not a line, that's why. Is that what you're going to say? Sort of. Yeah. It's not a line. Steve is right. You must draw a tangent line. Without a tangent line, I can't give you the mark for it. You need to show me that you understand a tangent line is required. The way to do that is to draw a tangent line. When I do my slope of my tangent line, I get around 0.42 meters per second. You might get something different. I didn't really care what the number was as long as I saw a tangent line and saw some sort of slope calculation based on that tangent line. I need to see your thinking. Without seeing your thinking, I'm not giving you the mark. Stop just writing answers. You know who you are out there. A instant 5 seconds. Now here, I still need to see a tangent line. Is it going to be pretty close to 5 over 5? Yeah, it's going to be pretty close. But that's lazy. I need a tangent line. It's around, I get 0.77, but I mean, if it's anywhere close to 1, I gave it to you. But I need that tangent line. Average acceleration from 0 to 90. That would be the slope of that line. From 0 to 90. Now that is going to be 20 over 90, right? Right? Because it's a straight line and goes through 0, 0. So 20 over, 90. .2 meters per second squared. Right? Is there any leeway on that one? No. No leeway. The only time there's leeway is when there's a tangent line. Okay, year after year after year, people struggle with question number 3. Okay, so let's watch very carefully here. For some silly reason, some people like to draw the VT graph first. I guess for some people that might make sense. For me, it looks like this. Displacement time. It doesn't say so, but if we can, we avoid the negatives, right? So a car's driving along, we can only assume it's going positive. Slows down as it enters a small village. So if it's driving down the highway, what does the position time graph look like? Straight. It's cruising at 100, right? Slows down. What does that look like? Little curve. Now it's not going as fast. Now it stops. What does stop look like? Flat. Speeding up. Going faster. Right? Good. Give me the nod so I know I can go on. I got a few blank looks out there. Now, is the velocity ever going to be negative? Does it ever go backwards? No, so I don't need to draw a negative part. Okay. Remember again, the velocity is the graph, is the slope of the graph of the dt graph, right? The slope of it. So what's the slope? You can do something like this. You can say, well, there it's pretty steep. I'm going to say positive, positive, meaning that it's, well, it's more positive than not, right? Positive, positive. And then it slows down. I'll label that just positive. And then it becomes, which is 0. And then it becomes positive again, and then it becomes even more positive. We have to graph those values. Positive, positive is going now. Is it constant positive, positive? Like, is it moving at a constant speed?
Yeah.
Yes. How do you show constant speed on a velocity time graph? flat, and then it slows down to a constant speed, and then it goes down to 0, and then it speeds up, and then it speeds up again.
You gave me a check mark, but I didn't do that.
Many people just sort of had the V or the U shape. They didn't have these sort of little levels in here. I usually count that as 1 out of 2.
Does it have to have those little numbers?
Yeah, because this is the slowing down, right? Here is the slowing down. Here's the stop. Here's the speeding up. And here's the back to highway speed, right? Does that make sense now that you see it?
I got a check mark and I didn't do that.
Yeah, you got the single drop.
X right there.
You got the single drop. You got 1 out of 2. Give me the yes, I get that now. Okay, now, here's where I quite often have to award zeros. Are there any negative slopes in the velocity time graph? Are there any negative slopes in the velocity time graph? Yeah, right there. Very steep negative, very steep negative. Positive, positive, and all the other places it is 0. So the acceleration time graph looks like this. What's the slope to begin with? 0. And then it becomes, for a very brief instant, very negative. And then it goes back to 0. And then it becomes very negative again. And then while it's stopped, it's 0. And then it becomes positive. And then it goes to a constant speed, a constant slope, flat, I mean. And then it becomes positive again. Now, not easy, is it? No. Yes, it is. However, I will argue with what Ben Roloff brought me in yesterday in grade 12 physics. And this compared to that is, well, quite a stretch. Yes, I'm not saying that this shouldn't be tough for you, right? It's a bit of a challenge, I get that. But that's what it looks like. Does that make sense now? And it's not like I haven't given you the skills to be able to do that. Did you have quite the complete understanding? Probably not yet. Hopefully now you do. Are we good? Yeah? And what are you graphing? You're graphing the slope. 0, negative, 0, negative, 0, positive, 0, because it slows down as it enters the village, and then it's stopped by a traffic light.
Oh,
it slows down, and then it has to.
I thought it was slowing down just to get to the
How does it get back to 0?
Which word?
Because like
Zero?
you start at 0 and then you go
Here?
after, yeah.
Because that just shows acceleration.
This just shows moving at a constant speed, right?
Yeah, I got that, like the acceleration.
Okay, so constant speed, 100,
Yeah,
slowing down to 50, constant 50,
got it.
slowing down to 0.
Yeah.
0, stopped, speeding up to 50, constant 50, speeding up to 100. It's tricky stuff. I won't dispute that. Now, number 4 as well always offers me the same challenges. I almost always get exactly the same stuff. There's always someone that wants to do this. Why is that wrong? Constant 2. What does constant mean? Stays the same. Because it's only worth 1. It's really, come on. Really? More than, no, it's worth 1. Constant 2 meters per second squared. Now, this is actually, and to be fair, I really do need to make this change. This is really instantaneous velocity. How fast is it going at that time? It's a, well, would it?
Would it really?
I don't know. How fast is it going at the time? Well, it's starting at rest. If it accelerates at 2 meters per second squared, that means that every second the speed is increasing by 2. And so the vast majority of you got this. Right? Hello, John. All right. The displacement. recall, if you will, the formula for displacement, which is V bar is D over T. V bar, which means average. Is this the average velocity?
No.
No. No. Okay, so if you started at 0 and after 1 second your speed was now 2, what would you have averaged over that 1 second? 1 meter per second. So 1 meter per second for 1 second takes you a distance of 1 meter. I will explain it one more time. If you start at 0 and then after 2 seconds your speed is 4, what have you averaged over those 2 seconds?
3.
You start at 0, you end at 4. What is the average between 0 and 4? 2. For how long? 2 seconds. A distance of 4 meters.
I just didn't do it that way.
I'll do it one more time. If you start at 0 and you, after 3 seconds, are going 6 meters per second, your average is 3. And you've averaged 3 for how long? 3 seconds. So you are now at a position of?
What?
You're averaging 3 meters per second over 3 seconds. Let's do one more until I get it from everyone. If you start at 0 and you average 8, you end at 8, your average is 4, and you averaged 4 over how long? 4 seconds, which is a distance of? What? Do I need to do the next one?
Yeah.
What's it going to be? It's really just, in a sense, it's really just this number squared, right? Why is that? Well, because this is going up by 2's, and then when you divide by 2, it's really a 1. And I won't get into that, but it's... Thank you. Don't worry, the vast majority of people get it wrong. Okay, given the velocity time graph below, the vast majority of you got this right. The correct answer is 27. You have to do area. I think this is 6, am I right? No, this one is 6. This one is minus 6. What's the other ones here? No, that's 3 to 6 is 3. 9, 18, 6 and minus 6? Yeah. Most people got that right. All right, you've got a couple minutes left. If you need to ask me a question, be ready for tomorrow. Don't be lazy on your cheat sheet.